All right, we are going to look at absolute value inequalities. So we're going to start with a concrete example, and then we're going to go a little bit more abstract. Okay, so intro. Okay, and we're going to start with this, which I know is an equals. Okay, and we're going to put it on a number line. Now, we've sort of already figured out that the equations got to go 3 to the right and 3 to the left. Okay, so what we end up with is x equals -3 and +3. That's the solutions that we end up with. So now what I'm going to do is I'm going to change the equals to an inequality. Less than 3. And we're going to see if we can't just guess or reasonably shade, right? Inequalities have shading, okay? Where the solutions might be, okay? Now, when we did the equals, we had the sentence that went with it, okay? So this is the set of x values whose distance is, I guess I have to have a distance from somewhere. Distance from is not equal to, is less than. Okay, less than. So the distance from 0 is less than 3. All right. Rapid fire. When I call on you, tell me a number whose distance from 0 is less than 3. Any number you want for distance that is less than 3. And Shane, -2, fantastic. Let me give myself a little number line here so that I can. Okay, so -2, agreed. Okay, Vince, yeah. Number whose distance is less than 3. 2, yes. Okie dokes. Tessa, 1, love it. Jack, 0. Non-integers are okay too. Jack S or other Jack. -1, thank you. Sorry, I forgot there's 2. Carson. What is it? Is negative, what's the distance from 0? It's got to be less than 3. Carson got the tricky question because all the integers are taken. So give me something that's not an integer. Make it a 0.5. 2.5. Yes. Okay. Davin. Ooh, 2.9 repeating. I like it. I'm going to put a little open circle here on 3 because I don't want to go past it. Okay, Oliver. -2.3, love it. Lucas. 1.5, yep. Andrew. 0.5, yep. Sydney?
-0.7.
Yes. Okay. Now, Josh, number whose distance is less than 3.
Negative 2.8.
Ooh, like it. Okay, so I am going to put an open circle. Now, you've all been giving me numbers that are between -3 and 3. We could keep going, but basically I should end up with like every single dot that's between those numbers. Okay, so the answer, the solution, okay, is the numbers that are between the endpoints, between, towards the center, because the distances are less than 3. If you want your distance to be less than, you better go towards the center. Okay. Now, this is a 3-part inequality. I'm going to put the word and, because we know what and means. It means intersection, overlapping. Okay. Ooh, greater than 3. Okay. Instead of me asking for points this time, could you just describe to me in words where I should put all of the points? Okay, everywhere except 3 and -3. Almost. I'll put my open circles there. And not quite everywhere. I need more specific. Leanna. Everywhere except between them. Right? Is all of these pieces have a distance that is more than? More than. Okay, so the set of values whose distance from 0 is more than, in this particular case, 3. Okay, so now I'm going to write the inequalities that describe that. X goes to the left of the negative side. Or, because I have an oars to row my boat that goes in between these two things. Or, X is more than 3. Notice that this one's kind of tricky. Look at how the inequality sign changed. It changed because I had to go to the left of the number to be more than for the distance. Okay, so this is the basic understanding of what happens when we have this absolute value inequality. Okay, so we have this, which turns into this. Less than turns into the in between. Between the endpoints. That's what it turns into. The greater than, okay, the greater than turns into the 2 parts, the ones that are outside the endpoints, between the endpoints, outside the endpoints, based on how we interpreted and figured out, right, what numbers actually make sense. All right, so now we're going to start our first example, and the A is going to be the betweens. Okay, we're going to set up some betweens and solve them. So absolute value is less than distance. Distance. So the first thing we do is isolate absolute value. Ready for this? Thinking bubble, right? You got to think before you continue. Okay, think. To make sure that we set it up correctly. Can distance be less than, right? Can absolute value be less than something? Make sure it makes sense before you continue. And then we split and solve. Same steps as before, right? It's just how you're setting it up. Split and solve. Okay, so how do you split this? Negative distance less than. You put the x's between because it's the less than. That is how you set it up. Okay, so this turns into this. Notice that the absolute value part disappears so that you can solve the three-part inequality. Okay, when you're on a number line, it looks like it's between the endpoints. Question. Okay. All right. It looks as though I'm out of space at the bottom, so I'm going to flip my page to actually do the first one. Ready? Okay. Examples. Absolute value, negative 2x plus 6 minus 1 less than 13. All right, let's do it. Isolate. Same thing I've always been doing. Isolate. Think. Oh, that's not a negative. Just make that a positive. Sorry. Okay. Here comes my thinking part. I've isolated it. I'm going to look at it, and I've got less than 12. Can the distance be less than 12? Wait. Yes, I apparently can't add. 14. Woo! Yes. Oopsies. Okay, can the distance be less than 12? 14. 14.
Yes.
Yes. Okay. Think if my distance is less than 14, when I split this, I know that it's going to be between the endpoints. Okay? So when I split this, okay, we get the negative 14, we get the positive 14, and the distance thing goes in the middle. Okay? Right? Because I know that it has to be between. Okay, so this is called a three-part inequality. When you solve this, you solve it just like an equation, except that you have three parts. So when you subtract 6, you got to do it from all three pieces. Okay? But all the same general rules apply. So when I divide by 2 in all of the spots. That's my inequality answer. And because I can represent these things multiple ways from the set and interval notation I learned about, Yes, Jonah.
How did you know it was?
Because it was less than. When the distance is less than, it has to go between. Good question, because that's the part that we're thinking about. Because it is a less than, that is why we chose to put it between. Okay? Less than. Okay. Interval notation, just in case. Yeah, yes. 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 It does. That goes along with the thinking. You got to just think about what absolute value means and make sure that it's reasonable before you continue. Correct. Okay. So, yeah, second one. All right, let's give you another one to try. Oh, yeah, I like this. Negative. Okay. You gotta isolate this thing before you think about what's gonna happen. Yes, you can. All right, Ariel, what would you do first?
I subtract the 2.
Okay, so minus 2. Yep. Okay, so minusing my 2. 3 minus. All right. Noah, what would you do next?
I'll subtract 3 from the size.
Ooh, I like it. See this? This is 3 subtracting this thing. This is still a number that was added. It's kind of funky because it was written in front, but it's what it is, okay? All right. Emma, what would you do next?
You would multiply both by -1 on both sides.
Yes, multiply or divide is fine. I'm gonna just divide. Okay. All right. Okay, hold on. Raise your hand. Yeah? Flip it. When you divide by a negative, you flip the inequality sign. High five for review knowledge. Okay, so right here, when you divide or multiply by the negative, you gotta flip the inequality thing. So this turns into a between. You gotta isolate before you decide. Okay. Woo, that was a lot of work. Okay, so isolate. All right. Flip my inequality, right? I'm just a little note to myself. Okay, multiply or divide by a negative. Flip inequality. Okay. It's just a little note. That's high five on that review knowledge. Okay. Isolate I gotta think about what's happening. I have less than 11. Okay, can your distance be less than 11? Yes, it can. Yes. Okay. Conclusion, it has to be between negative 11 and positive 11 because it's the less than. Okay, so now we're going to split and solve. So negative 11, bloop. Yes.
Wouldn't it be a less than equal to?
Say it again.
Yeah. Would it be an inequality sign with less than equal to?
Yes, it would. Thank you. I love your attention to detail. Okay. 3-part inequality. Right? You've just got 3 parts. Oh, this one's not too bad. Boo, 7. Okay. Woo, got it. All right, and we're just going to put it on a little number line here. I made a mistake on purpose. Can somebody tell me what it is? Yes, Tessa? The open circles. Okay, another volunteer. How do I do the interval notation for this inequality or graph? Yeah?
Would it be the brackets negative 15 and then 7?
Oh, fantastic. Woo! Okay. It's all about the thinking that happens on how you set these things up. All right. Exam. Okay. So now we're going to do A, B, C. C? Just absolute value more than distance. Okay. This is greater than. Greater, I spelled it wrong on purpose. Greater than. Okay, so when it is greater than, we are thinking, bubble, bubble, bubble. Can my distance be more than a number? Yes. When it's more than, it splits into the 2 pieces where it's x to the left of the negative distance or x to the right of the positive distance. Okay, why do we split it? When it's more than, you have to go to the outside. To the outside. Your distances have to go to the outside with an oars to row your boat with. Only way to get distances that are more than something is to move them away from the center. All right. Example. Okay, 1/2 x minus 3 plus 1 more than 3. All right. Isolate, think. Bless you. Okay, so here, gonna times both sides by 2, right? Think. All right. So can, I guess this is right. Okay, can my distance be more than, right? This is more than 4. Yes, it can be more than 4. There we go, I'll write it. Can the distance be more than 4? Yes, it can. All right, so what happens when distance is more than, greater, oars for your boat? You have to go to the left of -4 or to the right of +4, right? The thinking part is how you split this up. Can your distance be more than 4? It's gonna go to the outside. So it's gonna look like this, right? You gotta go left of the left side and right of the right side. That's the thinking part. Okay. So right here, I have to go to the left of the left side. That's why it says less than. That's like the part that should be shaded to the left of the end point. Because my distances have to be going away from the center. Or, okay, because I've got 2 oars to row my boat. All right, and solve. All right, so then we split. We already know how I'm splitting it because of my thinking. Yes?
So, when you said distance has to be greater than 4, why does it keep greater than equal to?
Oh, because the equal to doesn't affect the setup, it affects the endpoints. I was focusing more on the direction of the arrows instead of the endpoint. But yeah, you're right. It should have an equals because this is equal to. Okay. Don't try to combine your work, guys. If it's supposed to be 2 separate inequalities, make them separate. Okay? And number line. Okay, so I got a hard point. Woo. Okay, check that inequality out. Did I graph it right? Okay, 7. Look at that. 2 oars for my boat. 2 oars for my boat. Negative infinity, -1 hard bracket, 7 to positive infinity. Remember all that set interval notation, all these things matching up together. All of those things are different ways to write the solutions. Okay. You guys did a lot of thinking today. You have to do one more piece of thinking. Okay? One last piece. Ready? I'm just out of room. I'm just going to flip. Special solutions. What happens when you think about it and you're like, no. Or yes. Okay? So we're going to just think about, I like to call these special solutions because when I think about it, I say yes or I say no. Okay? So we either have no solution, which is what happens when I use my brain and I think about it and I say no, like we did with the negative distance earlier today, or potentially all real numbers. Okay, and this happens when I say yes. Like, yes, that has to work all the time, all the time. Okay, so we're going to do this by an example. And I'm going to start with an isolated statement, okay? Because I don't want to do like lots of extra writing. Less than what? Okay. Notice I already gave you the isolated statement, so we're just doing the thinking part. Okay, thinking bubble. Okay, I need yeses or nos. Anybody want to be brave enough to give me a yes or no for any of those bubbles? Yes, Davin? Which bubble is it? They could be different answers, so which bubble do you want to say no to? Sorry. The middle one. Okay, love it. No. Yeah, okay. Right, because absolute value cannot have a negative outcome. So no. So this is the no solution. Okay. Yes, Lucas?
Would the first one be no?
Yeah, can absolute value have less than a negative outcome? That's why thinking's so important, because it like eliminates some of the work if you think about it. So this is no solution. What about the last one?
Would it be yes?
It would be.
Because your solution would be greater than -2, so that leaves a whole possibility.
Yeah, because distance more. Is your distance always going to be more than -2? Yes. Oh. Guess what, guys? You do not solve past the thinking button if you already have the answer. Do not do any work. I promise you it gets kind of funky looking. And I will show it to you if you want, but I'm not going to do it in front of 30 people because I know I'm going to lose half of you when I do it. Okay? So all real numbers. I would not expect to see more work. If you put a little thinking bubble and you're like, yes, I can accept that as work. Yes.
But by also saying D is greater than -2, doesn't that mean like -1 is a possible answer?
But this statement will always be true. Now, whatever you plug in for X, you're not going to get those negative outcomes. But this statement is always true because these numbers, which are positive, it's always going to give you a true statement, which is all real. Okay. I think that pretty much covers it, guys. You just have to think about it before you split it up. Okay, yeah, we'll end there. Woo!